the next lecture. Then I invite Dr. Bok Jik Lee. He will talk about the South Korea space program.
Hello everyone. It's my great honor being here in this prestigious conference, and I especially appreciate the organizing body who invited me to this place. So let me just briefly introduce the Korean activities. First of all, I'm not authorized to give you this kind of talk. Perhaps this is only because I'm the first Korean attending this conference, so it is from my personal perspectives. So the talk will be into two parts. The first part it will be about the national government-driven programs. It's not extensive. I will just share some highlights. And then I'll go to the university level, student-driven R&D activities, and some examples from our own institute. You may have heard about this institute, the KARI, which is called KARI, Korea Aerospace Research Institute. Basically, this institute or agency derives from the policy making, and to the public service. Everything related to space development, they are governing and organizing. And this institute is just 30 years old this year. So most of the government-driven space programs to be introduced will be the achievement of KARI. So let me begin with our first practical satellite called COMSAT #1. COMSAT is the abbreviation for Korean Multipurpose Satellite. And the Korean name is dubbed as Arirang. If you have heard of the Arirang is the famous old Korean song, the name of the song. So that was developed jointly with US, and it operated successfully for over 8 years. And this was practically the foundation of our satellite development programs. And this was the image from our first satellite. And then the next one, the COMSAT #2, was mostly developed independently by ourselves. And we became the 7th country with 1 meter resolution in imaging with this satellite. And can you guess where it is? It is actually the city of Jeddah in Saudi Arabia. Actually, I used to work somewhere over here for 4 years in King Abdullah University of Science and Technology. And then COMSAT #3, that was fully developed and tested domestically. And it had the first one that had the sub-meter resolution. And it was launched about 7 years ago, in year 2012. And this is the kind of stunning image from COMSAT #3. It's the tallest building, perhaps, in Dubai. The next one is COMSAT #5. It was the first one that had equipped it with the synthetic aperture radar. So we are now able to observe the Earth regardless of the weather due to this SAR technology. So this is Korea's first all-weather SAR-equipped satellite. And this is one of the examples of SAR image at resolution of 3 meters. It's part of the Seoul. And COMSAT 3A, so because we were successful in developing COMSAT number 3, this is kind of a spin-off satellite with which we transferred the technology to the industry. So industry took over some technologies, and this became the world's first civilian satellites with high-resolution IR. So this is the IR image of the Han River, which is running across the Seoul city. Maybe somewhere around here, that's the Gangnam area, if you know. And then let's move on to those who run in much higher altitude at geosynchronous orbit. The COMSAT number 1, that was about 10 years old. This is the first Korean geostationary satellite, and with this one we became the 7th country of having their own weather satellite. And the name, that's Cheollian in Korean. Cheollian, if you write in Chinese character, it's these 3 characters. The first one is meaning 1,000. The second one is the unit of distance. It is very old unit, meaning this one means 400 meters. And this is representing the eye of human. So we have this kind of word for the especially capable man who can see over 40 kilometers or something. Then we call such person with this name, and so we thought Cheollian into this satellite. And this is the image from this satellite observing our globe.
Confirmed it. And you can see revealed to the elements is our second passenger, due for separation in a minute. Waiting for confirmation by the DDO on the separation of our lower passenger. Again, the same waiting, the same suspense, only this time.
Et séparation GeoComSat 2A.
For the GeoComSat people.
So this was very recent event. The Ariane space aerospace, they launched our second version of GeoComSat, and it was successful. And the first image from this one was received very recently, a few months back. So we are still communicating with this satellite. So this is kind of the overall roadmap of our space programs. And although the slide is really crowded and you cannot read it, but year 2019, this year is somewhere around here. And actually, one of them from here should be the lunar orbiter, which will be slightly delayed due to the discrepancy between the requirement and our technological readiness. But a lot of things are ahead of our schedule. And let me move on to the launcher developments. So we started from developing a sounding rocket, the scientific rockets, and we developed 3 versions. The KSR number 1 was for testing the solid rocket single stage. Then later on, we tested two-stage rockets. And lastly, for the sounding rockets, we tested liquid rocket engine capability. Then, as you may well know, this was the our first space launcher, and that was the first stage was developed by Russia. The 170-ton class engine was developed by Russia, and we took over the development of second stage, which was 8-ton class. And by that time, the payload was about 100 kilograms. This is the scene of the launching. And by doing this, actually, we learned a lot from Russian. And also, to launch this first version of launch vehicle, we constructed the launching and test site in the southern end of our peninsula. So this shows our recent development for our second version of launching vehicle. And this is the ground test of the 75-ton engine, which is running about 220 seconds without any problem. That was only done last year. It will be burning over a few minutes, so let me just skip. And then a few months later, we actually used it on an engine test vehicle. This is not the real launcher, but we just tested one of the elements of the engine using kind of a dummy launcher. Half a year ago, and we are finalizing the development of the whole system. So this will be our true second version of launch vehicle, and the one you've seen just now was testing with only one component of four of them, consisting the first stage of the true second version launch vehicle. And in the end, it will be carrying about 1.5 ton payload to low Earth orbit. So this is just an illustration about how our engine would look like. This is about our first stage. Consists of 4 of 75 tons engines. And the same thing will be used for our second stage as well. By the way, this is the liquid oxygen and kerosene based engine. Finally, this is the 7-ton class third stage engine. So this is going to be tested in 2 years. So these are the collection of our development for launching vehicles. And we are also in the middle of development for satellite-based augmentation system, which helps the information from GPS. And using satellites, basically, we can increase the accuracy of the positioning information. And next year, this will be in public service, and year 2012 to 22, this will be fully serviced for aviation as well. This shows our ground station headquarters located in the middle of Korea. The city is called Daejeon. And this is the worldwide network of our ground stations. So we've got the ground stations scattered in several places. This figure shows our reseller network for selling our images from our satellites. So there are hundreds and I think actually millions of images taken out of our satellites, and it is being commercialized by these reseller companies. And also we serve our observation, remote sensing data to neighboring countries. So these countries are under our data coverage, including, I think, Russia as well. And let me move on to the university-driven activities. So our university, Seoul National, we are kind of the headquarters of the multi-university-driven activity for space propulsion research. It is called SPRC, and it consists of 3 groups of researching topics. And personally, I am involved in this group 1, and where we study the injector design and combustion instability, and I do the numerical simulation to predict the combustion instability that can happen in the rocket engines. And we've got another group for coupling of structure and acoustics and propulsion. It's about the structural vibration of launching vehicles. And the third one is about the variable thrust development. They are mostly focused on developing the Pintle engine, Pintle injector, aiming to develop something for reusable launching vehicles. And from here, it's just student-driven activities from our university. The first one is called the SNU satellite number 1 and 1B. So they are twins. And it was a 2U unit CubeSat, and started from 2012. And it was part of QB50 European space program. And we participated there, and it was actually deployed from the International Space Station. So this shows our in-house development with the student. So EQM testing at Kyushu Tech, and also the SATRAC, the Institute for Satellite in Korea, and FM flight model assembly in our university. And that was delivered to ISIS. You can see the twins. And those were successfully deployed. This is SNUSat number 1, and it passed. It's already gone, but that was 1B. But somehow the ID for those 2 were mixed up, and we spent almost 1 year to get the telemetry signal. And so it was launched 2 years ago, and we spent 1 year for the first signal. And now we are, for the next year, I mean the last year, we received over 1,000 beacons from this satellite. And probably we guess that the solar panel of these satellites were not deployed. So we are still analyzing the beacon from this. And in the meantime, we started the development of second version. Now it's a little bit bigger with 3 units CubeSat, and started about 4 years ago. And it has some missions, scientific missions, and it was actually launched very recently. So this shows our engineering model development, and showing several parts that consist the bus of the satellite. And we've gone through all the vibration test, and also thermal vacuum test, and also some tests for its own mission. So it was designed for remote sensing. So NVDI test of the field image was the ground tested. And this shows the bus assembly of our second version of CubeSat. And it was delivered. The launcher was Falcon, which we'll introduce later. So it was launched few months back. It was launched at the end of last year using SpaceX Falcon 9 launcher. And soon it was successfully deployed, but according to our analysis, it has undergone some unstable attitude. So it's overly spinning with high rate. So we unlinked and commanded the safe mode of this satellite, and we are waiting for the spinning rate to be stabilized due to the natural drags, and it will be taking several months, perhaps. This is a rather abrupt conclude, but because our activity is never ending, so there couldn't be any conclusion. So thank you for your attention, and let me finish for your having lunch at the right timing. Okay, thank you. Thank you.
So this concluded the morning section. We have now lunch. The volunteers will guide us. I don't know also where it is, so the volunteers will help us. Thank you.